In a dried-up river delta on Mars, the most compelling evidence to date for ancient life has been found. This discovery comes from NASA's Perseverance rover, a robotic geologist the size of a car, currently exploring an ancient dried-up river delta on the red planet. The findings, recently published in the scientific journal Nature, represent the most compelling clue yet in the centuries-long search for life beyond Earth. The rover found these clues in July of 2024, and scientists have spent the past year analyzing the data to understand what it means. It's a find that could reshape our understanding of our planetary neighbor. So what exactly did the rover find inside this rock? First, we'll decode this chemical fingerprint and understand why it looks so much like a sign of life. Then, we'll explore if ordinary geology could have created it without any microbes. And finally, we'll see how this single discovery changes everything for the ambitious mission to bring Martian samples back to Earth.
The story begins in Jezero crater, a 45-kilometer-wide basin that, billions of years ago, was filled with water. Perseverance has been exploring this ancient lakebed since it landed in February of 2021. This specific discovery was made in a rocky outcrop called the Bright Angel Formation, which lies along the edge of an even older river valley that once fed the lake. The composition of clay and silt in this area is important. On our own planet, these fine-grained materials are excellent at preserving the delicate remains of past microbial life. This finding shows that Mars not only had water, but also had the right kinds of environments to preserve potential signs of life. To analyze these rocks, Perseverance uses a suite of sophisticated tools at the end of its robotic arm. Two instruments were key here: Pixel and Sherlock. Pixel, the planetary instrument for X-ray lithochemistry, uses a tiny X-ray beam to map the chemical elements in a rock, revealing its composition in microscopic detail. At its side is Sherlock, which uses a laser to scan for organic molecules in minerals, hunting for the chemical building blocks of life. This allows scientists to get a detailed chemical analysis from millions of miles away. The specific rock that caught the science team's attention is an arrowhead-shaped stone named Cheyava Falls. It was here, within the Bright Angel Formation, that the rover's instruments detected a rich cocktail of chemical compounds. The rocks are full of organic carbon, sulfur, rust, and phosphorus. This combination could have served as a rich source of energy for ancient microbes. This discovery in a former river valley confirms that Mars once possessed environments with all the necessary ingredients for life as we know it. So, the rover has found a promising rock in an ancient lake bed, full of the right chemical ingredients for life. But now, let's zoom in on the feature that makes this particular rock, Cheyava Falls, so compelling. A strange pattern scientists have nicknamed leopard spots.
Up close, the rover's high-resolution imagers revealed that the spots are not random. They are structured, millimeter-scale patterns where distinct chemical reactions once took place. These aren't just stains, they are reaction fronts, boundaries where chemicals met and transformed. The instrument Sherlock, with its ability to detect organic matter, found one of the strongest signals for carbon-based molecules the mission has seen to date, right within these spots. This confirmed the rock was worth sampling, using one of the rover's precious titanium tubes to drill a core, now named Sapphire Canyon.
With the sample secured, the PIXL instrument went to work mapping the exact mineralogy of the leopard spots. The results were striking. The spots contained two specific iron-rich minerals, vivianite and greigite. This pairing is incredibly significant. On Earth, vivianite, an iron phosphate mineral, often forms in sediments near decaying organic matter, like in peat bogs. Greigite, an iron sulfide, can be directly produced by certain types of bacteria. Together, they suggest a process called a redox reaction took place, where electrons were moved from the organic matter to the iron and sulfur in the mud. This is precisely the kind of reaction microbes use to get energy.
Of course, scientists must be cautious. These minerals can be created without the presence of life. Such abiotic processes, however, typically require conditions like sustained high temperatures or highly acidic water.
The instruments on Perseverance have examined the surrounding rocks and found no evidence for either of these conditions at the Bright Angel site. While this doesn't completely rule out a non-biological origin, it makes the biological explanation more plausible. Perhaps one of the most surprising aspects of this discovery is the age of the rock. Initial analyses suggest these are some of the younger sedimentary rocks the mission has investigated. Scientists had previously assumed that any potential signs of ancient Martian life would be confined to much older rock formations. This finding suggests that Mars could have remained habitable for a longer period than previously thought, expanding the timeline for when life could have existed on the red planet.
This discovery doesn't just change our map of where to look for life on Mars. It changes when we should be looking, suggesting the planet could have supported life for much longer than our older models predicted. Right now, the data from Cheyava Falls is being scrutinized by scientists around the globe. To bring order to such a profound claim, NASA uses a framework called the Confidence of Life Detection Scale, or COLD. This 7-level scale helps scientists assess and communicate how confident they are in a potential sign of life, preventing them from making premature claims. This finding from Perseverance sits on the early rungs of that ladder. It's a compelling signal, but it's far from a definitive proof of life.
The immediate future of this discovery hinges on one of the most ambitious space missions ever conceived, Mars Sample Return. The Sapphire Canyon core is one of 27 samples the rover has collected, sealed in tubes and in some cases strategically placed on the Martian surface for a future pickup. This joint campaign by NASA and the European Space Agency aims to launch a lander to Mars, retrieve these samples, launch them back into Mars orbit, and have another spacecraft capture them for the journey home. It is the only way to get these precious materials into advanced laboratories on Earth, where they can be analyzed with equipment far too large and complex to send to Mars. Only then can we definitively determine if the leopard spots were created by microbes or by some unknown geology.
However, the Mars Sample Return mission faces an uncertain future, with debates over its high cost and complex architecture causing delays and threatening its cancellation. This new discovery of a potential biosignature adds a profound sense of urgency. The rock that could answer the question of life on Mars is sitting there, waiting to be collected. Meanwhile, other nations are planning their own sample return missions, potentially creating a new kind of space race. If this sample, once analyzed on Earth, confirms a biological origin, the long-term consequences are immense. It would mean that life started on 2 separate planets in our own solar system, suggesting that life may be common throughout the universe. It would fundamentally alter future exploration, requiring even stricter protocols to protect both Earth from Martian contamination and any potential Martian ecosystem from us. Every future mission, robotic and eventually human, would be recontextualized from one of pure exploration to one of astrobiological study and planetary protection.
So, did NASA find life on Mars? Not yet. But in a rock named Cheyava Falls, the Perseverance rover found the most compelling chemical fingerprint to date. A combination of minerals, organic matter, and distinct structures that, on our world, are a calling card of microbes. The answer is locked inside the Sapphire Canyon sample, 300 million miles away, waiting for a ride home.